A planet 120 light-years away is sliding across a faint red star, and its air is writing a fingerprint into the dark. A gold mirror in space is catching that fingerprint right now. The pattern looks weak, then strange, then almost impossible, and one tiny chemical hint is turning a routine observation into a question nobody can safely answer yet. If you like real mysteries where the facts are even stranger than the rumor, subscribe now. Stay close because this story only gets more unsettling the deeper you follow it. The wild version of this story says the James Webb Space Telescope caught a signal from deep space and NASA went quiet. That sounds like a hidden radio message, a warning, or maybe proof that something out there is trying to speak. But the real story is more subtle, more scientific, and in some ways even more shocking than the clickbait version. Because what Webb may have found is not a voice, but a chemical sign that should not be easy to ignore. To understand why people are so worked up, we need to go back to what James Webb was built to do. Webb is not just a giant camera floating in space, it is an infrared telescope, which means it studies heat and light our eyes cannot see, including faint clues from very far away. That makes it one of the best tools humans have ever built for studying planets around other stars. One of those planets is called K2-18b. It was first found in 2015 by NASA's K2 mission, which looked for tiny dips in starlight caused by planets crossing their stars. K2-18b circles a cool red dwarf star in the constellation Leo, and from the start, it stood out as a world that did not fit neatly into the old boxes. Scientists first expected the best life search targets to look a lot like Earth, small, rocky, not too hot, not too cold, and maybe wrapped in an atmosphere with signs of water and oxygen. But space keeps reminding us that it does not care what we expected to find. K2-18b is not a second Earth at all, and that is exactly why it became so important. This planet is about 2.6 times wider than Earth and about 8.6 times more massive. That means it is bigger, heavier, and likely very different inside. It sits in what scientists call the habitable zone, the region where a planet could in theory have liquid water. In simple words, it is at a distance from its star where the temperature might allow water to stay wet instead of freezing or boiling away. That sounds promising, but there is a catch. Planets between the size of Earth and Neptune are common in our galaxy, yet our own solar system has none, so scientists do not have a close example they can visit with probes or compare in detail. These worlds are still a puzzle, and every new measurement can change the picture. Here's how Webb studies a planet like this. When K2-18b passes in front of its star, a tiny bit of starlight moves through the planet's atmosphere before reaching the telescope. Different gases block different colors of light, so if you break that light into a pattern called a spectrum, you can look for missing pieces and tell which gases might be there. That sounds clean and simple, but in real life it is painfully hard. The planet is tiny next to the star, the light changes small, and the signal has to cross about 120 light-years of space before it reaches a telescope that is itself dealing with heat, instruments, math, and noise. This is the first big pattern in the story. Scientists expected that if K2-18b was just another thick, gassy world, its atmosphere might look dull or messy. Instead, in 2023, Webb found something sharp enough to excite almost everybody in the field. The telescope detected methane and carbon dioxide in the atmosphere, which immediately made the planet far more interesting. That result mattered for a second reason too. The data also seemed to show a shortage of ammonia. Some researchers said that mix, methane, carbon dioxide, and little ammonia could fit a strange kind of planet called a Hycean world. That means a world with a hydrogen-rich atmosphere and maybe a deep ocean underneath. A Hycean planet is not a word most people grew up hearing because the idea itself is still new. It does not mean a twin of Earth. That means a larger world that might still have places where life could survive, especially in an ocean below a thick atmosphere. In other words, scientists were being pushed toward a new idea of where life might hide. Did you expect the first really tempting life clue to come from a world that does not even look like Earth? If that surprises you, tap like, subscribe, and tell me whether you would still count an ocean world as home. Now comes the part people remember. Along with methane and carbon dioxide, the 2023 Webb data also gave a very weak hint of another molecule. That molecule was dimethyl sulfide, usually shortened to DMS. And on Earth, DMS is strongly linked to life, especially tiny living things in the ocean. That is where the word signal starts to get twisted online. Webb did not hear a beep, it did not detect a message in code, it measured a possible chemical feature, a faint pattern in starlight that may match a gas, but if that gas is really there, the meaning could be huge. On Earth, most dimethyl sulfide in the atmosphere comes from marine life, especially phytoplankton, tiny ocean organisms. So when scientists saw even a possible sign of DMS on a faraway planet, they paid attention fast, not because it proved aliens, but because it hinted that a living process might be shaping an alien sky. Still, even the team behind the finding did not call it proof. NASA's own release in 2023 said the DMS result was less robust, which means less secure and not yet confirmed. The lead researchers said more Webb observations would be needed. That is not silence, that is caution, and in science, caution is everything. Then in 2025, the story became louder. A team at the University of Cambridge used Webb again, this time with its mid-infrared instrument, also called MIRI. They reported stronger hints of sulfur-based gases, including DMS and a related molecule called DMDS. And suddenly the whole world started asking the same question. Was this finally the moment? Was the strongest telescope ever built looking at the strongest sign of life ever seen beyond our solar system? The Cambridge team called it the strongest hint yet of possible biological activity outside the solar system. That is a careful sentence, but it still hits like thunder. They also reported something else that made the claim feel even bigger. The amount of these gases, if the reading is correct, appeared to be thousands of times higher than what we usually see in Earth's atmosphere. Cambridge said the level could be over 10 parts per million, and that is a tiny fraction, but in planetary air studies it is loud enough to matter. But now the second pattern starts. Scientists expected that stronger data would settle the issue. Instead, stronger data opened even more arguments. Some experts got excited, while others warned that the evidence was still below the gold standard needed for a true discovery. And that standard matters more here than almost anywhere else. In science, a result like this is often judged by something called sigma. You do not need the math. Think of it as a way to measure how likely a result is real instead of random noise. The 2025 hint was strong, but it was still not at the famous 5 sigma level used for major discovery claims. The BBC reported that the team said there was still about a 0.3% chance the reading could be a fluke. That may sound tiny, but when the claim is life on another world, tiny is not tiny enough. Scientists want the chance of error pushed down to something closer to 1 in many millions, and even that would not end the mystery. NASA explained this clearly in a 2025 blog post about how Webb supports the search for life. A single possible biosignature gas would not count as the discovery of life. Scientists would still need follow-up work, other kinds of evidence, and strong tests against false positives. That word matters too. False positives. A false positive is when nature creates a sign that looks biological, even if no life made it. It is like seeing footprints in fog and realizing later they were just cracks in the ground. Space is full of ways to fool us, especially when the signals are small and the hopes are huge. So what could fool us here? One problem is that DMS is not as simple as people think. The Planetary Society noted that scientists have found trace amounts of DMS in comets and in the gas between stars. Those levels are tiny and probably not enough to explain K2-18b by themselves, but they prove one key fact. Nature can make this stuff without life. If that is true, then the mystery changes. The question stops being, did Webb find life, and becomes, what process is making this gas if the gas is even there? Could sunlight, pressure, heat, or unknown chemistry build the same signal? Or are we seeing a mix of gases that only looks like DMS from far away? What do you think is more likely right now, a strange new chemical trick or a living ocean on a world we have never seen up close? Leave a comment with your guess and subscribe if you want to follow where the evidence goes next. There is another problem hiding beneath the atmosphere. Scientists are still debating what K2-18b actually is. One team may see signs of an ocean world, another may see a hot, dense mini Neptune, another may argue that the lower layers could be so extreme that life as we know it would struggle badly. And the early exciting picture was this: a deep ocean, a hydrogen-rich sky, and chemistry that might fit a living sea. But critics pointed out that the same missing ammonia could be explained in other ways. For example, the planet could have a molten rock layer or interior conditions nothing like a calm ocean world. That matters because the whole life argument depends on context. A gas that means one thing on a cool, wet world may mean something else on a hotter, harsher one. NASA has stressed exactly this point. You cannot read one molecule in isolation and pretend the rest of the planet does not matter. Then came one of the most uncomfortable details in the whole story. A later independent reanalysis of some earlier Webb data did not confirm all the same atmospheric features with equal confidence. According to the Planetary Society, another group found no significant evidence of carbon dioxide or DMS in that earlier data set. That does not erase the claim, but it does remind everyone how fragile these readings can be. This is what makes exoplanet science both amazing and maddening. Everything we think we know about these worlds comes from tiny changes in light. We are not landing there. We are not scooping up the air with a machine. We are reading shadows and missing colors from a distance so large that the numbers stop feeling real. K2-18b is roughly 700 trillion miles away, which the BBC used to show just how absurd that distance is for human travel. No ship we can build today is going there. No robot is coming back with a sample. For now, the only way we touch that planet is with light, math, and patience. And patience is exactly what the internet hates. A headline wants a yes or no, aliens or no aliens. NASA hiding the truth, or NASA making the biggest announcement in history. But real science often lives in a slower place where maybe is the most honest word anyone can say. So when people ask why NASA sounds quiet, the answer is almost boring. NASA is not silent because there is nothing to say. NASA is careful because there is too much at stake to say the wrong thing. Their own public pages describe the result, explain the limits, and say clearly that more work is needed. In other words, the silence is not a cover-up. It is the sound of scientists refusing to turn a maybe into a miracle before the evidence is ready. That can feel unsatisfying if you want instant answers. But if the topic is life beyond Earth, careful science is not a weakness. It is the only thing standing between wonder and self-deception. Here's another twist people miss. The word signal makes many viewers imagine radio waves like the famous WOW signal or a fast radio burst from deep space. That is not what this is. Webb studies light from stars and atmospheres, not mysterious coded messages from intelligent beings. The signal here is a pattern in a spectrum, not a sentence in the dark. Still, do not make the opposite mistake and think that means it is small news. If Webb has really found a biosignature gas on a planet in the habitable zone, that would be one of the biggest scientific clues in modern history. Not final proof, but a clue so strong that entire research plans, telescope time, and future missions would shift around it. And that is happening now. Researchers are testing new models. They are asking whether DMS or DMDS can be produced by non-living chemistry at the levels reported. They are arguing about the planet's structure, temperature, clouds, pressure, and history. This is not a finished story sitting in a textbook. It is a live investigation unfolding in real time. The lead researcher, Niku Madhusudan, said he hoped stronger confirmation could come within 1 to 2 years. That is fast by space science standards. But even if the signal strengthens, other teams will still need to challenge it. A claim this large has to survive attack from every angle. If it does, that is when the world truly changes. And if it does not survive, that matters too. A false alarm would still teach scientists how to avoid fooling themselves on the next planet. NASA's blog made that point very clearly. Negative results help improve future searches because they teach us which biosignatures can mislead and which tests matter most. Even disappointment can move the field forward. Have you ever noticed that the most honest space stories are not the ones with the loudest answers, but the ones with the hardest tests? If you want more of that kind of science, subscribe and tell me whether you trust cautious results more than dramatic headlines. There is a bigger reason this case feels different from older life claims. Past hints of alien life often came from Mars rocks, strange meteorites, or chemical puzzles inside our own solar system. Those were exciting but messy and often easy to argue over. K2-18b is different because the signal comes from a whole planet's atmosphere measured by a telescope designed for this kind of work. Webb is showing that the search for life is no longer just science fiction or hopeful talk. It is turning into remote detective work. We can now study the gases around worlds that humans will never visit in our lifetimes. That means the question, are we alone, is moving from philosophy toward measurement, but that shift brings a danger. The closer science gets to an answer, the more people want to jump ahead of the evidence. A chemical hint becomes a confirmed biosignature. A biosignature becomes alien life. Alien life becomes intelligent life. And by the end of one social media post, a careful data point has turned into a fake first contact story. That is why the real version matters. The true drama is not weaker than the myth, it is stronger. Because what is happening here is that human beings have built a machine powerful enough to read the sky of a faraway world, and the sky of that world may be whispering something we have waited centuries to hear. Think about how strange that is. For most of history, the stars were just lights. Then they became suns. Then some of those suns turned out to have planets. Now one of those planets may be showing chemistry tied to life. The distance has not changed, but our reach has. Still, the planet itself refuses to become simple. Some models suggest K2-18b may have an ocean under a hydrogen atmosphere. Other models say it could be too hot, too pressured, or too weird for Earth-like life. If the ocean exists, we do not know how deep it is. If life exists, we do not know what form it would take. And that leads to another important gap between expectation and reality. People expect life elsewhere to mean forests, fish, insects, or cities. Scientists are talking about microbes, basic chemistry, maybe simple living systems in a vast alien sea. The first sign of life beyond Earth, if it ever comes, may not look grand at all. It may arrive as a tiny mismatch in light. That does not make it small. In some ways, it makes it bigger. Because if simple life can appear on a world very unlike Earth, then life may not be rare. It may be a natural outcome when the right ingredients meet time, energy, and a stable place to grow. That would change how we see the whole galaxy. Now imagine the opposite. Imagine the signal weakens. Imagine better analysis shows the gas was never there, or that non-living chemistry can make it after all. Even then, this moment still matters because it proves we have entered an age where such tests are possible, and that alone is a giant leap. NASA also points toward what comes next beyond Webb. Future missions like the planned Habitable Worlds Observatory are meant to study Earth-like planets around sun-like stars in even greater detail. Webb is opening the path, even if it was not built only for life hunting. It is teaching scientists which worlds to chase and which clues demand the most caution. So the real question is not whether NASA is silent. The real question is whether humanity is finally hearing the universe clearly enough to test one of its oldest ideas, not with myths, not with guesswork, but with instruments sharp enough to pull chemistry out of darkness. That is why this story hits so hard. It sits right on the edge between maybe and history. One side says this is just another disputed signal in a noisy field. And the other side says we may be watching the first serious step toward proving that life is not unique to Earth. And right now, nobody can honestly say which side will win. Do you think we are living through the first real chapter of finding life beyond Earth, or just another lesson in how easily space can fool us? Drop your answer below, and if you enjoy careful mystery more than loud hype, hit like and subscribe. There is also a human reason this story spreads so fast. We all feel the size of the universe, even if we cannot picture it. A planet more than 120 light years away should be far beyond our emotional reach. And yet one odd pattern in its atmosphere suddenly makes it feel close, almost personal. Because the question underneath it belongs to all of us. If K2-18b really holds a living ocean, then life did not happen only once. That would mean biology is not just an Earth story. It would mean the universe has more than rocks, gas, fire, and silence. It would mean that somewhere under a foreign sky, chemistry crossed the line into something alive, and if that turns out to be true, the meaning goes far beyond astronomy. And it touches religion, philosophy, our sense of loneliness, even how we value life here at home. If life is common, then Earth is not the only place where the universe learned to breathe. If life is rare, then every living thing on this planet becomes even more precious than we already knew. That is why scientists move so carefully. They are not just checking a graph, they are guarding the doorway to one of the biggest statements our species could ever make. Once you say life has been found beyond Earth, you cannot casually pull the words back. So they test, retest, argue, and wait. And while they do, the public fills the silence with stories, and some stories say the truth is being hidden, some say the discovery is already locked in. But the deepest version of the story is simpler. We are standing at the limit of our knowledge, and the signal is just strong enough to tempt us forward, not yet strong enough to let us relax. That tension is what makes this one unforgettable. Webb has not delivered a clean answer, it has delivered a challenge. Can we separate hope from evidence? Can we measure an alien world well enough to know whether a living process is shaping its air? Can we stay patient when the answer feels close enough to taste? Right now, more observations, more models, and more criticism are pushing against this mystery from every direction. That is exactly what should happen. A real discovery becomes stronger when smart people try to break it and fail. So the next few years may matter more than the headline that first dragged your attention here. The work after the excitement is where truth is decided, and remember, this is only one planet. Webb is looking at other worlds too. Each one adds a little more context, a little more comparison, a little more pressure on our old ideas about habitability. K2-18b may end up being the first big breakthrough, or just the first big warning. Either way, it is teaching us how to read the living possibilities of the cosmos. That may be the most amazing part of all. The universe is not suddenly becoming strange, it was always strange. What is changing is us. Our tools are getting good enough to notice, our questions are getting sharper, and our patience is being tested by answers that come one faint signal at a time. So no, the truth is not that Webb caught an alien message while NASA hid in silence. The truth is harder, slower, and more profound. Webb may have detected a chemical hint in the atmosphere of a distant world that could point toward life, but only if that hint survives every brutal test science can throw at it. And right now that fight is still underway. If this signal holds up, history changes. If it falls apart, our search gets smarter. Either way, we are watching the moment when humanity learns how to ask the universe the biggest question in the most serious way it ever has. That is not silence. That is the sound of a species listening carefully for the first time. So before you go, subscribe and turn on notifications if you want the next update the moment it lands. Then tell me this in the comments. Do you think K2-18b is hiding life or hiding a lesson about how careful we need to be? And share this with someone who loves space mysteries but wants the real science behind the hype. Thanks for watching.